Hello everyone, here is Mustafa. In this video I'm going to speak about reaction quotient. Let's get started. The reaction quotient. For an equilibrium reaction of the form of A plus B is giving C plus D, where the small letters are referring to the coefficients of both reactants and products at constant temperature, Q is equal to the concentration of the products to the power of their coefficients over the concentration of the reactants to the power of their coefficients. This is the same as equilibrium constant Kc. The difference is just the system is not necessarily to be at equilibrium when we are using Q. Okay, so what's the benefit from calculating Q? We have here simple reaction. R is giving P. Kc is equal to 2 for this reaction. Kc, of course, the concentration of products to the power of its coefficient over the concentration of the reactants to the power of its coefficient. Q, same idea. We have three scenarios where we can study why we are calculating Q, or what's the difference between Q and Kc. If you are given that Q is equal to 3, so here Q is greater than Kc because Kc for this reaction is 2. What does it mean when Q is greater than Kc? Directly it means that the products are higher than the reactants. The matter that makes the value for Q higher than Kc, So we are concerned about the products here. So the products are greater than the reactants. What's the effect? How the reaction will respond to reach to the equilibrium? Of course, if we have a high concentration of products, for the reaction to reach to the equilibrium, it has to shift to the left. The reaction should be shifted to the left hand side, so the reverse reaction is favored. Scenario number 2. What is scenario number 2? If we are given, as you can see here, Q is equal to 1, which means that Q is lower than Kc. What does it mean by Q is lower than Kc? So now we can assume directly that the reactants here for this case are greater than the products. So what is the effect or what is the effect on the reaction if we have a greater a concentration of reactants? The reaction, of course, should shift to the right. For that reason, the forward reaction is favored. Okay, what is the third scenario? The third scenario is when Q is equal to Kc. Q is equal to Kc, which means that if Q is equal to Kc, it means that the reaction is occurring at equilibrium. We have here an example about the reaction quotient, or how we can use it in the following reaction. CO plus H2O is giving CO2 plus H2. We have here the concentration of CO, the concentration of H2O, the concentration of CO2, the concentration of H2. Kc is equal to 1. It's clear that this reaction is not at equilibrium. Why it's not at equilibrium? Because if we check the concentration of the products, where's the products? We have CO2 and H2. So we have 2 by 2 over where are the reactants? Reactants are 1 and 1. Of course, it will not give 1. So this is Q. This is not Kc because it's not at equilibrium. Here we have Q is equal to 4, which means that Q is greater than Kc. What does it mean? When we have Q greater than Kc, of course, we can directly understand that the products are higher than the concentration of the products are higher than the concentration of the reactants. So the reaction will should shift to the left to oppose the change. So we have here, as we said, Q is greater than K, so the products are in excess and the equilibrium will shift to the left.